Okay, so today what we're going to do is we're going to talk about the derivatives of exponentials and logs. And so to derive an exponential or a log, there's a formula that we could use in both scenarios. And so I'm just going to dive in first and explain what the formula is without actually proving how we get the formula. So when we go to take the derivative of an exponential function, in other words, we want d dx of a to the u, the derivative of that fits the formula a to the u times the natural log of a, and then we have to tack on the derivative of du dx on the end of that. Now, we could take a long route to get that answer, but in most cases when you take the AP exam, you don't want to derive that derivative. It's just quicker and easier to plug and chug into this formula. So if I have an exponential function like a to the u, and I take the derivative of a to the u, the derivative is a to the u times the natural log of a, and then we tack on that derivative of u, which is usually some sort of expression of x. So here we have y equals e to the x plus x squared. And so in this case, it's easier, and I can use this formula if I take my function and make it look like a to the u. And then my derivative is all this stuff on the end. So a is actually the base of the exponential, and u is usually some sort of expression of x. And then we have to tack on the derivative of that expression. So if I let this be y equals e to the u, then u would be equal to x plus x squared, and then du dx would be equal to 1 plus 2x. So to find y prime of this, y prime would just be e to the u times the natural log of a, which is the base, in this case is e, times du dx. Okay, and that's just plugging that into this formula. And the one thing that's neat about the natural log of e, or the natural log of e, is remember the natural log is just a logarithmic function with the base e, so those cancel out. And I get the natural log of e is 1, so I get y prime is actually equal to e to the u du dx. If I were to write this in terms of x, it would be e to the x dy dx. So usually when you have a derivative of e of something, it's just e to that something plus you tack on the derivative. So now if I plug in u and du dx, this is what I get. Any questions?